So the derivative, because the slope of the tangent is the derivative. So the derivative here, what is it? So the derivative of the first term is just itself. The second term is 3x squared, and the third term is 35x to the power 6. Okay. Now look, I'm going to explain why we don't have, why this one is a long and this one is a long. What is the domain of the derivative? What is it? Can you see here from its expression?
R.
It is R because this is polynomial R and this is polynomial R, and this is x squared R. Yeah, I'm sorry, not x squared. E to the power x is R. So R, everything is R. So we don't have any exception here. It works for all numbers. So the domain is R. That means Y has derivative where everywhere. That means we don't have vertical tangent. Because what does mean vertical tangent? Vertical tangent at A means what?
If we have an exception in the domain.
No, vertical tangent means the derivative is. If we don't have infinity or minus infinity, it is R. It is defined everywhere. Okay, we don't have. فهمتوا يعني derivative exists everywhere. This function here, for example, this is A and this is X axis. This function, what is the domain? What is the domain here? R except because here it is at infinity is A. I'm sorry, at A it is infinity. At A it is infinity. But here we don't have infinity at any number. Look, at any number, Y prime exists. The domain is R. فهمتوا هذول يعني I hope it is clear. Huh? If you have vertical tangent at A means f prime of A does not exist because it is infinity or minus infinity or something like that, or maybe it is infinity from one side and minus infinity from the other side. Okay, but here f prime exists everywhere. Look, has derivative everywhere, exists everywhere because the domain is R. I hope you understand this. Now about horizontal, what do we do? Why we do not have horizontal? Horizontal is easy to see. Look, I will show you. This term here is positive, yes or not? Non-negative, positive or zero, because x to the power 6 multiplied by positive number. And this term here is positive also or equals 0. It is non-negative. This term, because x squared, and this term here, this is true or false, this one, if I write like this. This is true or not?
No, bigger only.
Okay, good. So this is strictly bigger than 0, strictly greater than 0. So the sum of these numbers, it will be how? The sum, it will be greater than 0 or just strictly greater than 0. It will be greater than 0 because one of them is greater than 0. Look, this is always greater than 0. We know that from Math101-Rec6-midterm. And the other two terms, maybe they are equal to 0, but even if they are equal to 0, You add them to a number that is positive, it will give you something strictly positive. Because the first number is strictly positive, you add something that is 0 or positive, you get something that's strictly positive, okay? So that means is never 0, never. And what does mean horizontal tangent? Horizontal tangent means slope is equal to
0.
0. That means the derivative is 0, so impossible. We don't have horizontal. So no horizontal tangent. And no vertical tangent. Also. No horizontal, no vertical. Okay? So this is how you solve this problem here. And 181 here, a good problem here. If you know how to do this, (181) or 171, I don't remember. Yes, this one here, 181. Look, try to do this, okay? And I give you like 4 or 5 minutes. Just try it as much as you can. Think about it. It is about the tangent, but it's a little bit advanced. Just think about it. Okay.
Okay, let's do it together, okay?
So they give you a line, y plus x is equal to 2. This is the equation of the line. It is tangent to the curve y is equal to c over x plus 2. And then they ask to find c. Okay. So it is tangent at one point. What is this point? So I have here, let me just copy this. Okay, how do you find the slope of this line? Well, write it in minus x plus 2. So where is the slope? Slope is minus 1, is the coefficient of x. Okay, and this is what? This is the tangent. The tangent here, the tangent, let's say at the point M, A, B, or alpha beta. Let me put alpha beta like so if you read the answer, you will understand. So the slope is minus 1. That what is 1? Minus 1, now it is the derivative of f where? At alpha. So this is f of x. Let's call it f of x. But now what is the derivative of f? The derivative of f, you take derivative here, you will find that is minus c over x plus 2 squared. So do the quotient rule and you will find it, okay? So here my line is minus c over.
Sir, I have a question.
What is it?
How did you know that without using the whole quotient rule that it is equal to negative c over x?
No, I used the quotient rule. No, the quotient rule. Look, the quotient rule. This is not the quotient. The quotient rule like that. F over G. Okay, this one is F prime G minus F G prime over G squared. But this is also the quotient rule. This is special case of quotient rule. The numerator is 1. 1 over F. What is it? It will be just minus F prime over F squared.
You can use it all the time?
Yeah. Because look, here replace F by 1. Instead of F, you have 1. So here you have, what is the derivative of 1 is 0. So this one, it becomes 0. And what is F is 1. So it is minus G over G, minus G prime over G squared. Minus F prime over F squared. Whatever you have in the denominator. So we use it. So this rule, use it here. So I have what? I have C over X plus 2. C is just constant. So it will be C, the derivative of this. So it will be C times minus the derivative of X plus 2 minus F prime over F squared. And what is the derivative of X plus 2 is 1, because here 0 and the derivative of X prime is 1. So it will be minus 1. Minus 1, so minus C over X plus 2 squared. Okay? If you don't know, you apply the quotient rule. You apply the general quotient rule, yes.
We don't know what's the value of x, so how can we get C?
Yes, yes. This I'm telling you, this problem is a good problem if you know how to solve it. You solve all the problems about normal line and tangent line. So just let me finish. Do you understand this?
Yes, but how can we get C? Because we don't have X.
Yeah, I didn't finish yet. Just let me. If someone does not understand this, he can raise his hand. Raise his hand. Please raise your hand if you don't understand this one. You understand? Okay, this is an equation. Okay, so this is what we have here. This is what we have here. This is this one here, second one. You see it? Okay. Now we have another one. What is the other one? From where we get it? So this point here, this point, it is where the line is tangent to the graph. So it belongs to the line, and also it belongs to the graph. Graph of the function, this one, c over x plus 2. And this one, what is the line? Y is minus x plus 2. You agree with that? This is the tangent that is, so it satisfies both equations. That means here you apply, here you replace y by beta. So we have beta is minus alpha plus 2. And here we have beta is c over alpha plus 2. Okay, so these two equations, they give you one equation. What is it? Look, beta is equal to the first number and the beta is equal to the second number. It means what? It means that the first number is same as the second number. So minus alpha plus 2 is same as c over alpha plus 2, because both of them, they are equal to beta. Okay, so this is the second equation here. This is the second equation here. Can you see it? Okay, so now I have two equations. Look. I have two equations. The first one is, the second one is this one. This one here. And the first one given by the derivative, minus 1 is minus c over alpha plus 2 squared. Now the first one, eliminate the denominator or cross multiply, you will have what? Alpha plus 2 squared is equal to minus c. Is that correct? This is what I have here. Same as here. No, I have mistake here. Where is the mistake?
It's equal to c, not to minus c.
No, فين الغلط عندي هنا؟ شو look, minus alpha plus 2 times alpha plus 2 is c. So here what I have? Difference of squares. I have 4 minus alpha. Can you see that? I have 4 minus alpha squared is c. Is that clear? This one here also cross multiply. You will have alpha plus 2 squared is, you cancel minus with minus. It is just c. So I have these two equations here. These two equations, look, I have c is equal to the first number and c is equal to the second number. They give me this. 4 minus alpha squared is alpha plus 2. This is 2 here. 2 squared. And then I solve for alpha. Solve for alpha now. I solve for alpha how? I can I can do it like this. So here I can distribute here alpha squared plus 4 alpha plus 4. And then cancel alpha from here and here. Okay. And 4 from here and here. I will have alpha is equal to 0. You can solve it this way. Is that clear? You cannot have alpha is equal to -2. Anyway, from the beginning, it is not equal to -2 because it makes the denominator to 0. Anyway, you can solve it this way. Alpha is equal to 0. But I'm looking for C. I'm looking, so I go up. For example, yeah, you can use this one, for example, or you can use this, or you can this one. So alpha is 0, you will get C. If alpha is 0, you will get C is 4. C is 4. This is the answer.
Doctor,
نعم.
how can alpha square minus alpha square cancel with alpha square?
لا حول ولا قوة إلا بالله. I did a mistake here. This is what I was looking for, alpha -2. Okay, let me solve it another way, like your friends. I'm sorry, sometimes I do mistake with numbers. Thank you very much for notifying me. Thank you very much. So which we can do it here, we can do 2 minus alpha times 2 plus alpha is equal to 2 plus alpha times 2 plus alpha. Okay, is that clear now? This is clear. We cannot cancel 2 plus alpha. We cannot cancel because 2 plus alpha, maybe it is 0. We don't cancel 0. So we bring all of them to one side. We bring all of them to one side and we take 2 plus alpha as common factor. It is multiplied by what? 2 minus alpha minus 2 minus alpha. 2 plus alpha, okay? Just I bring, or I moved to the right side, the left side. Is that clear? Is that clear? And on the right side, I left with 0. Now I have 2 plus alpha times minus alpha times minus 2. So you cancel 2 here. You cancel 2. Minus alpha with minus alpha is minus 2 alpha. Minus 2 alpha is equal to 0. That means what? It means alpha is equal to 0 or alpha is minus 2. Now this one you reject. Why do you reject? Because look at the beginning, alpha cannot be minus 2 because it makes the denominator equal to 0. So reject it. So you keep only alpha is equal to 0. After that, you replace, you come here, you come, for example, here. Anyway, for example, you come here if you want. You replace alpha by 0, you get C is equal to 4. That's it. This is the answer.
From where you get the second equation?
Okay, this one or this one?
Yes, the upper one.
This.
No, the upper
This one. This one here.
Yes.
From the fact that the point belongs both to the tangent line and to the curve. It is in the curve and in the tangent on the curve and on the tangent line. Look.
Oh, okay, because it's a tangent.
Please mute your microphone. Talk to each other. Please mute your microphone. Do you understand that? Clear?
Yes, because it's a tangent.
Look, I have point. It belongs to the tangent. So it satisfies the equation of the tangent. What is the equation of the tangent? The equation of the tangent line is, so y, which is beta, is minus x plus 2, minus alpha plus 2. And then this is because it belongs to the tangent. Also, it belongs to the curve. It belongs to the curve, so I have beta is c over alpha plus 2. And then you make this one equal to this one because they are both of them equal to beta. Is that clear?
Yes. If there's a normal line, I put it the red blocker of the slope, right?
Yes, you know what to do with you take the slope of the tangent, you make it, you multiply it by minus, and you flip it, you reverse it, you take its reciprocal.
It would be x plus 2.
Okay, let me continue now. Okay, let me continue. Someone is talking and they can hear some noise. Please mute your microphone. If someone is talking, he needs to mute his microphone, please. Let's do another problem. This one is something easy, only about numbers. So quotient rule, look, quotient rule applied correctly. This kind of problem, what you need to do. Quotient rule, apply it correctly. And then you need to know what is the derivative of secant, which is secant times tangent, and what is the derivative of tangent, which is secant square. After that, you substitute 0 for x. You substitute 0 for x. You have to do it. You have also to remember what we have done in Math 002. That means what is tangent of 0, what is secant of 0, these things. You know, in the exam, they may give you, for example, pi over 2 or pi over 4, secant of pi over 4, tangent pi, secant 3 pi over 2. You never know. So these things, try to review them before you go to the exam, okay? Here, definition of using the definition of derivative, let me finish. Let me skip this one here. Here, okay, this is good. Let's do this. Let's do this together. Limits x minus 2 times x plus 2, difference of squares, over sine of 2 minus x, when x goes to 2. Okay, you can do it like this. Limit of x plus 2 times the limit of minus 2 minus x, okay? X minus 2. Why I'm doing that? You are asking me what?
I want to see the original question.
Here is the original question. The limit, this limit, what is it?
Okay.
Just here I take the difference of squares. Okay, here x minus 2, so this 2 minus x, call it like theta or beta or y or v or u. Let me call it theta. So here, so this one, so when x goes to 2, this will give me 4. Substitute, you will get 4. And here limit, look, when x goes to 2, what happens to theta? It goes to 0. So you replace x by 2, you will get to 0. So I forget about x going to 2. Only I keep theta going to 0. Minus theta over sine of theta. So what is this number here? 1. This is 1. 1 times minus is minus 1. Minus 1 times 4 is minus 4, okay? So this the answer is minus 4.
Doctor, I solved it by L'Hopital.
Wallahi, we didn't reach L'Hopital yet. L'Hopital is chapter 4.
It's really very easy by L'Hopital.
Yeah, do it. If you know L'Hopital, apply L'Hopital rule.
Okay, thank you.
Okay. You know, you need to make the mark in the exam. You have to make it correctly. Do it all by all means that you know. Any way that give you and it gives you the correct answer, and you do it. Okay, this problem here, look here, you have to. So this problem, I think, they may be difficult for the students because they need to read and understand what they are trying to say here. So think about like few minutes and then we can do it together, okay? Think about this. Okay, so let's find the answer here. So this is the formula for V is pi r squared times h. So dv dt is equal to what? So pi is constant, d of r squared h by d of t. And then this is like just r squared h all prime. So what you do? Product rule. So it is pi times dr square over dt times h plus r square dh over dt. Is that clear? Check the derivative. If you want to do it with this is most likely 3.7, but we can do it even with our knowledge. This is 3.7, I think, but it can be given as 3.2, for example, because all what we have here is product rule. Okay, so pi here. Again, here we have like chain rule because the derivative of r squared is 2r dr over dt times h times plus r squared dh dt. Okay, so pi times 2. So now r is given. So when the radius is 1 centimeter, so the radius is 1. Okay, it is given, it is 1. At this instant where the radius is 1. Okay, and the rate of the radius, what is it? Is 3 centimeters per second. And h at this instant is 4. Okay? Plus r squared. What is r squared here? Again, it is 1 squared times the rate of change of h. What is the rate of change is 2. So it will be, here I have pi times everything. Yeah? Pi is multiplied by everything. Because I pull it out at the beginning, look. So it is multiplied. So p times 26. 24 plus 2, 26 pi. And the unit is centimeter cubed per second. Okay. And here I have 26 pi per 26 pi centimeter cube per second. If you want to, you can also do it with just like that. If you want, just do it like that. V prime is pi r square h prime, and do it with a derivative like that. So it will be pi times r square h prime. So pi times, so the derivative of r square times h plus r square times the derivative of h. The derivative of r square, what is it? Is 2r r prime times h plus r squared times h prime. So like this. And then you replace. So here 2 times 1 times 3 times 4 plus 1 squared times 2. And then it will give you 26 pi. And the unit is centimeter cube by second. Okay, this is derivative of cotangent. That's it. But you have 2y here. No, this is 3.5. No, problem like that, this is 3.5. Okay, this is 3.5. Because now x is function of y. So this should be 3.5. Which one of the following statement is true? If f is differentiable, then so let's skip this one. Which one is true? So there is one more problem here that is good. Okay, this is good also. You can do it. And this one also is good. This one, okay. This one. You can do it 2 different ways, but this is one way. So 1 minus cosine of theta, how you, so what you are going to do here, so tangent, make it like sine over cosine, and secant make it 1 over cosine, okay, and then it will give you cosine plus 1 over cosine. And then multiply both numerator and denominator by 1 plus cosine of theta, 1 plus cosine of theta. Here, second, just they keep it. Didn't change, they didn't make it 1 over cosine, just they keep it second here. And then you multiply 1 minus cosine times 1 plus cosine, it will give you 1 minus cosine squared, which is sine squared. Sine squared. Okay? And this cosine that is here, they move it up to the numerator. Okay, and then sine squared, you divide it by sine, it will give you 1 sine, okay? So sine theta over theta, this is what I have here. Because you cancel this sine, you simplify this sine squared with sine, it will give you just 1 sine in the numerator, and you divide it by theta. And you multiply everything by cosine of theta over this product here. The product here is just 4, because theta is going to 0. Secant of 0 is 1. So it will be 1 plus 1, which is 2. And cosine of 0 is 1. So 1 plus 1 is 2. So it will be 1 over 4 times 1. This problem here, so I have few minutes. So I will do for you this. So I have function like this. F of x is equal to f of x g of sine of x and here we are asked to find f prime at 0 or at pi, at pi. First you need to find the general form of f prime. Okay, so take the derivative here. So how you take the derivative? Apply chain rule. So this is derivative of f at its argument. Okay, times the derivative of the argument. So this is how you solve this problem here. Now, the derivative of the argument was what is it? You apply the product rule. Is x prime times g of sine of x plus x times g of sine of x prime. If you do it like that, it's wrong. You have to do it like this. And then all of these two terms, they are multiplied by this term here, which is the same as before. Okay, after that, so we keep the first term, x prime is 1. So we will have g of sine of x plus x. What is the derivative of g of sine of x? Again, apply chain rule. Chain rule, it will be the derivative of g at sine of at its argument times the derivative of the argument. But sine of x prime is just cosine of x. Okay, and all of this is multiplied by f prime of x times g of sine of x. Now substitute, this is f prime of x. So f prime of pi, what is it? So g of 0, because sine of pi is 0, okay? Here we have 0. Sine of pi is 0 plus x, which is pi. Cosine of pi is minus 1. Cosine of pi is minus 1. And g prime of 0, because sine of pi is 0 here. This one is 0. All of it multiplied by f prime of what? Pi, x is pi times g of 0. Okay, now let's go back to the question. F prime of pi is 1, g prime of 0 is 2 over pi. Where is g? So here you have 2 over pi. 2 over pi. G of 0 is 1. G of this is 1. Huh? Here we have 1. 1 plus pi times minus 1 times 2 over pi. All multiplied by f prime of g of 0 is 1. Huh? G of 0 is 1. So f prime of pi. So this number here, what is it? It is minus 1. Huh? Because you cancel pi, minus 2 plus 1 is minus 1. And f prime of pi is 1. So the answer is minus 1, okay? Now they give you extra information. G of pi is not needed. 1 is just extra, it is not needed. Huh? That's all for today, okay? So these problems are from different sections, from 3.4, 3.2, and so 3.3 and on. And see you inshallah next time. Good luck in your exam.
Thank you, Doctor.
Okay, thank you.